Hello, my name is Andy, and I'm a rising senior at Lowell High School. And this is my second main project, which is an omni-directional robot controlled by a PS2 controller. For this main project, there are 3 different components to this robot. There are the mechanical aspects, electrical aspects, and the coding aspects of this. For the mechanical aspect, it was pretty simple. It was just a triangular chassis, as you see here. A few other parts, a surface to hold all the electronic components, 3 motors mounted to the sides, a shaft, and wheels on each side. The electrical aspects were a little bit more difficult because there were some problems that occurred, including numerous fires that I accidentally caused, and I burnt my breadboard as a result. But then eventually I fixed those problems because I put some heat shrink on exposed wires so that they wouldn't short each other. And I'll explain how the electrical components work. Okay, so mounted on the bottom of a robot is a 7.2 volt battery to power the motors. So it starts here, it goes across this 2.2 ohm power resistor. Then it goes across this jumper wire to the red rail, which connects all the way down. And so here are the 3 motor controllers for the 3 different motors. There are 3 different wires on each controller. There's the black wire, which connects to the ground. There's the orange wire, which is the power source, or which is the power. And there's white, which connects to the ports on the Arduino. And here are the receiver pins. And these receiver pins are set up to match a gamepad function on the coding of the robot. So it just makes it easier to code. And there's the black and red wires in the center. The black one's for ground, and then the red one is for the 3.3 volt power, 3.3 volt port on the Arduino. And over here is a 9 volt battery, and that is used to power the Arduino itself. So the last component of this is the coding component, and the coding was the most difficult part of the project. So the coding involves coding the left and right analog sticks to control the robot. The left analog stick does the directional movement, while the right analog stick does the rotational movement. And coding the 4 common directions, north, south, east, west, were pretty simple because all we had to do was I had to think about vectors and have 2 wheels spin while the last one remains stationary. But then if we wanted to code directions that were more difficult, such as northwest, southwest, those are a lot more difficult because we need to take the input data into account. And the way I did this was to think about what translation for a robot is. So in translational movement, like this, the motors do not turn to go to this direction. The motors remain parallel to the side of the frames. So we had to think about the lateral movement of the motors. And then basically what the code does is to find the right way to control the 3 lateral movements of the motors so that the robot moves in the direction that we wanted based on the input data angle. And do some intense trigonometry and geometry. We were able to make a right triangle using the lateral movement as a side. The shaft is perpendicular to the frame even after the translation, so we could make a right triangle. And the hypotenuse is just the motor here, the motors on each frame with the new motor, which we call ABC primes. And that's how we made the right triangle. And to find the lateral side of the movement, we decided to try to find an angle because in translational movement, most of the points are parallel, so it makes finding angles really simple. And after some calculations, we found out that in relation to the input data, this one was theta minus 120, this one was theta minus 240 because it's an equilateral triangle, and this one was theta minus 360, which is essentially the same as theta because in a unit circle, if you go 360, it's just the same location. And that's how we related the input data to the lateral motion of the wheels, and that's how we got the robot to move. So now I will attempt to meander across these cones and back. So
Yeah.